Hey students, before you get this video started, make sure you have your math notebook and something to write with. Today we're covering section 5.4, which is about the distributive property. And our learning target today is I can apply the distributive property to generate equivalent expressions. So let's go ahead and start by talking about what the distributive property even is. What is the distributive property? Well, before I even tell you what it is, let me show you an example of a situation in which we would use the distributive property. If I had something that looked like this, 3, and then right next to it in parentheses, 7 plus 2. So we've learned in previous chapters that when a number is directly touching the outside of our parentheses, they're being multiplied together. It's kind of like when we have a coefficient and a variable and they're touching directly, they're multiplied together. When we have a number touching the parentheses, it's multiplied together. But we have several things in the parentheses. There's not just a single number inside of here, there are multiple things. That means the thing on the outside is multiplied by all of the things on the inside. It's not just multiplied by the first thing, it's multiplied by everything inside of the parentheses. So the distributive property says that we're going to multiply the thing on the outside by everything, by every single thing inside. So it's just saying, hey, if you have a number touching the outside of the parentheses, if they are multiplied, it's multiplied by everything on the inside. So let me show you how that would work. In this example, this 3 is multiplied by everything inside these parentheses. It's multiplied by the 7 and it's multiplied by the 2. We are going to distribute it to both. We are going to multiply it by distribute it to both. 3 times 7 plus 3 times 2. I distributed that 3. I multiplied by that 3 by everything on the inside, the 7 and the 2. Another example, if we had 3 multiplied by this group, 7 minus 2. Again, the thing on the outside, 3, needs to be multiplied by everything on the inside. It gets distributed to everything. 3 times 7 minus 3 times 2. So in both situations, I multiplied the thing on the outside by everything inside my grouping symbols. I distributed to everything. One little tip to kind of remember when to use this or how this works, I like to think of the example of if I have an ice cream truck. Let's say this is an ice cream truck. It's got a little cone on top. And you and your friend both go to get ice cream. You both bring money. You are a group, you and your friend together. The ice cream truck is going to distribute ice cream to both of you. You are both going to get ice cream. Now you're holding a little cone, and they're going to hold a little cone. Okay, so when you have a group, you and your friend are a group, the thing on the outside, that ice cream truck, is going to distribute ice cream to everybody in the group. That thing on the outside is going to get multiplied by everything inside. So this is just kind of maybe a word trick to remember what this means. So let's do some examples. Example 1, simplify with the distributive property. So part A, we have 4 multiplied by the group n plus 5. So the 4 is touching the parentheses. That means they are multiplied together. But remember, it's multiplied by every single thing on the inside. So I have to distribute it I have to multiply it by everything inside. So I have 4 times n plus 4 times 5. I distributed it I multiplied it by everything inside, n and 5. Now 4 times n, how could we rewrite that a little bit shorter? Well, that would just be 4n. 4n means 4 times n. We don't need that multiplication symbol in the middle. And 4 times 5, we know that that is 20. So when we use the distributive property here, we simplified our expression to be 4n plus 20. We distributed, we multiplied the thing on the outside by everything on the inside. All right, we're going to do several more examples. Let's move on to example 1, part B. Here we have 12 multiplied by the group 2y minus 3. So again, thing on the outside touching these parentheses. That means it's multiplied by, it gets distributed to everything inside, the 2y and the 3. So 12 times 2y, that's our first part. We have a subtraction symbol, and then that 12 is also multiplied by the 3, 12 times 3. So how could I simplify 12 times 2y? Well, if I have 12 groups of 2y, 12 groups of 2 is 24. That means I have 24 y's. 12 groups of 2 y's is 24 y. You can see that we just multiplied those two numbers, the 12 and the coefficient, and that y just gets tacked onto the end of there. 12 times 2 is 24, so 12 times 2y is 24y. And then 12 times 3, we can multiply that, and we get 36. So again, the thing on the outside gets multiplied by, gets distributed to everything on the inside. Part C, we have 1/2 multiplied by the group 6y minus 2z. So we have a number touching the parentheses, so it's multiplied by, it gets distributed to everything on the inside, the 6y and the 2z. So first we have 1/2 times 6y, subtracted, subtraction symbol, minus 1/2 times 2z. So we distributed, we multiplied that 1/2 by everything inside. Now let's simplify this a little bit. 1/2 times 6y. Well, last time we learned that when we have something like this, when we have a term with a coefficient, a variable with a coefficient, we can just multiply that number by the coefficient to make a new coefficient. So 1/2 times 6, what is 1/2 of 6? Well, that would be 3. So 1/2 times 6y, that is 3y. Again, we just multiplied that 1/2 by the coefficient to give it a new coefficient. 1/2 times 6 makes 3. 1/2 times 6y is 3y. Minus, same situation here, 1/2 times 2z. 1/2 times 2, what's half of 2? That would be 1. So 1/2 times 2z would be 1z. Now there's actually one more thing we can do here to make this just a little bit simpler. You might be like, Miss Reed, where is that? Well, 1 times z, 1z, that is just the same as z. Remember how we said any variable alone has an invisible coefficient of 1? That means we do not need to write the coefficient of 1. It always exists there. It's invisible because 1 times z makes z. So again, we distributed the thing on the outside. We multiplied it by everything on the inside. And part D, 9 multiplied by the group 6 plus x plus 2. So again, we have a number touching the outside of the parentheses. That means it's multiplied by everything on the inside. It gets distributed to everything on the inside, the 6, the x, and the 2. So first we have 9 times 6 plus 9 times x plus 9 times 2. We multiplied 9 by everything inside, 6x and 2. So now let's simplify this down a little bit. 9 times 6 is 54. Plus 9 times x, we can just write 9x. Remember, 9x means 9 times x. Plus 9 times 2, which is 18. So again, I distributed, I multiplied the number on the outside by every single thing on the inside. But hold on. This expression right here looks a bit similar to the things that we simplified in section 5.3. We have things added together, so we can use the properties of addition, the commutative and associative properties, to kind of rearrange this and simplify it a bit. So let's see how that might work. Well, I see a 54 and I see an 18, and I know I can actually add those together. I can figure out what 54 plus 18 is, but right now they're not next to each other, so I can't really add them together. So my first thing I want to do is I want to switch the order here. I want to change the order so that the 54 and the 18 are next to each other. So I'm going to go ahead and just swap the 54 and the 9x. That way 54 and 18 are next to each other. The reason I can change the order is because of the commutative property. Commutative property says when things are added together, you can change the order and the answer is not going to change. I can switch those, and my answer is still exactly the same. Now, the 54 and the 18 are next to each other, but I would like them to be in the same group. That way I can actually add them together. I can just get one number from these two things. I can add them together to make one term. Now, we learned in section 5.3 that I actually can do that. I can group 54 and 18 together because when things are added together, I can change the grouping of them. That is using the associative property. The associative property says when I add things together, I can change the grouping and it doesn't change the answer. Now that they're grouped together, I can go ahead and add those. 54 plus 18, that would be 72. Don't forget that 9x that's added. And look at that, 9x plus 72. This has one less term than we had up top. We made it a little bit simpler, a little bit shorter. What we just did using these properties of addition is called combining like terms. We took things that are alike and we combined them to make this a little shorter and simpler. So let's talk about how do we combine like terms. I know I just did an example, but let's talk about it a little bit more. So first, what are like terms? How do we know which things to combine? Well, like terms are terms that have the same variable, terms that both have an x attached to them, terms that both have a y attached to them. What about in the last example, though, when things had no variable? Those would also be like terms. Because they both do not have a variable, they're also alike. Remember, those things are called constants. Constants have no variable. So like terms either have the same variable or do not have a variable at all. They are constant. All right, so let's do an example of this. So I have the expression 5x plus 19 plus 2x minus 2. And I want to combine the like terms. So I'm going to start step 1. We're going to write it over here, is to identify the like terms. We have to know what are alike. And I'm going to do this using shapes. What I mean by that is I'm going to draw the same shapes around my like terms. That way I can easily see which terms are alike. So I see a term right here at the beginning that says 5x. This term has an x on it. So I want to identify any other terms with an x on them. Not 19, not minus 2, but this 2x also has an x on it. So these are like terms. They are alike. They have the same variable, x. Now you'll notice I included that addition symbol when I put my box. That's because this addition symbol goes with this specific term. That means this term is always added. So I want to make sure I know that in my next step. You'll see that in just a moment. I also have this term right here, plus 19. This is a constant. It's a term with no variable. So I'm going to put a circle around that one. Do I have any other terms that are constants? Yes, I do, right here, minus 2. That is also a constant. So these are alike. They both are constants. They have no variable. Again, we're including the symbol, the addition or subtraction symbol in front of the term because that tells us if this term is added or subtracted. So now we're ready for step 2. Step 2 is we're going to rearrange so the like terms are next to each other. We're going to rearrange so that my like terms are next to each other, just like we did in our last example, right? We rearranged our expression so the like terms would be next to each other. So I want this 5x and this 2x to be next to each other, and I want this 19 and this minus 2 to be next to each other. So I'm just going to go ahead and swap these two in the middle like that. That way 5x and 2x are next to each other, and the 19 and minus 2 are next to each other. This is where it was important to have that symbol in front. It reminded me that this needs to say plus 2x and plus 19 because, again, that symbol goes with that term. That means I'm always adding the 2x and adding the 19. I kept the same symbol in front of them. All right, so that's done. So we're ready for step 3. Step 3 is to actually combine the like terms. We are finally ready to combine them. So right here, I have my 5x and my 2x. And right here, I have my 19 and my minus 2, my negative 2. So I'm ready to combine these together. 5x plus 2x, how does that work? Well, if I have 5 apples, 5x, and 2 apples, 2x, how many apples is that? That would be 7 apples. So 5 x's plus 2 x's, that's 7 x's. And then right here, 19 minus 2. Again, you can see why it was important to keep the same symbols in front of each term. That way I know I'm supposed to be subtracting 2, not adding 2, subtracting 2. 19 minus 2, that is 17. So my final simplified expression here is 7x plus 17. We went from something with 4 terms all the way down to 2 terms. So that's why this is helpful. It makes things a little bit shorter and simpler for us. So let's try some examples. I know this is a little bit weird, but let's just try a few examples. So we're now into example 2, and here we are going to be simplifying the expression. We're going to simplify. So that could mean using the distributive property or combining like terms or both. So starting with part A, we have 3x plus 9 plus 2x minus 5. So I don't see any need for the distributive property. There's nothing multiplied by a group, but I do see some like terms. So I'm going to combine some like terms. So I'm going to identify them with my shapes first. That's step 1. So this term has an x on it, 3x. And I also see this term has an x on it, 2x. So those are alike. I also have this term that says plus 9. That is a constant. It has no variable. And another term that is a constant with no variable, minus 5. So I'm done with step 1. I've identified my like terms. I have 2 terms with x's on them and 2 constants. Now I'm going to rearrange my expression so that my like terms are next to each other. I want 3x and 2x next to each other, and I want 9 and 5 next to each other. So I'm going to go ahead and swap these two in the middle. That way 3x and 2x are right next to each other, as well as this 9 and minus 5. Again, it's important that we keep that same symbol that was in front of our term up here, that it's still in front of our terms down here. So we're done with step 2. We've rearranged our expression. That means we are ready to actually combine our like terms. So we're going to combine 3x and 2x, 3x plus 2x. So if I have 3 x's and I add 2 more x's, I'm at 5 x's. And right here, I have 9 minus 5. Again, we had a minus symbol up here, minus 5. I need to be subtracting 5 down here as well. 9 minus 5 is 4. So my final simplified expression here is 5x plus 4. We went from 4 terms down to 2. Part B, I have y plus y plus y. So step 1, identify the like terms. Part B, I have y plus y plus y. So I don't see any need for the distributive property here. There's nothing multiplied by a group, but I do see some like terms. So we are going to combine like terms. So this term has a y on it. This term also has a y on it. And this one also has a y on it. They are all alike. So step 2 would be to rearrange my expression so they're next to each other, but they're already next to each other. So it's just going to stay the way it is, y plus y plus y. But you might be wondering, Miss Reed, how am I supposed to combine these? They don't have coefficients. How do I know how many y's I'm adding together? Well, remember, a coefficient, the number in front of the variable, is multiplied by the variable. So what could I multiply y by that wouldn't change it, that would make it still just y? That would be 1. 1 times y is still just y. So each of these represents 1 y. If I have 1 y plus another y plus another y, 1, 1, and 1, that makes 3 y's altogether. So when I simplify this expression all the way down, I get 3y. We went from 3 terms to just 1. All right, we're going to move into example C. Example 2, part C. Here we have 7z plus 2 multiplied by the group z minus 5y. So before I get into combining like terms, you'll notice that I do have a number multiplied by a group. This 2 is touching this parenthesis. It's multiplied by this group. So I do need to start by using the distributive property. I'm going to distribute, I'm going to multiply this 2 by everything inside, the z and the 5y. It is not getting multiplied by this 7z because that is separate. That is not part of this group. It is being added to the rest of this, so that's getting totally left alone. All right, so 7z is getting left alone. Let's see what I got when I use the distributive property. 2 times z, that makes 2z minus 2 times 5y. 2 times 5 is 10, so 10y. So I've used the distributive property. Now I still want to check and see, are there any like terms to combine? Well, it actually looks like there are, so let's start by identifying them using our shapes. This term has a z on it, and this term also has a z on it, so those are alike. This term over here, minus 10y, does not seem to have anything like it. It's the only term with a y on it. So that one's not going to be combined with anything else. Step 2 would be to rearrange our expression so the like terms are next to each other, but they already are. 7z and 2z are already right next to each other. So no need for that. We are ready to actually combine the like terms. So really that means we're just going to be combining 7z and 2z. 7z's plus 2z's, that makes 9z's. And then we still have minus 10y on the end. 9z minus 10y. So here you can see we used a combination of multiple things. We used distributive property and we combined like terms to get our expression as simple as possible. We went from this thing all the way down to this thing. Part D, we have 3 multiplied by the group b plus 5 plus b plus 2. So just like last time, I do see a spot to use the distributive property here. I see this 3 multiplied by this group. It's touching this parentheses. It's multiplied by this group. So I do need to distribute this 3. I need to multiply this 3 by everything in this group, the b and the 5. You might be like, Miss Reed, why didn't you multiply it by the b and the 2 over here? Well, these are not inside this group. These are not part of this group, so this 3 does not get distributed to them. These are just added separately. So 3 times b, that's 3b, plus 3 times 5, which is 15. And then don't forget, we still have plus b and plus 2 on the end of this. We've used the distributive property, but I see like terms, so let's go ahead and combine those. So I have 3b, that has a b on it, and this term right here, just b, also has a b on it. Those are alike. And I have this term here, plus 15. That's a constant, and another constant right here, plus 2. So I've identified my like terms using shapes. That's step 1. Step 2 is to rearrange the expression so that the like terms are next to each other. I want this b next to the 3b and this 15 next to the 2. So I'm just going to swap the middle two. That way it looks like 3b plus b plus 15 plus 2. Now I'm ready to go ahead and actually combine my like terms. So I have 3b's plus b. Well, what coefficient does b have? Oh yeah, there's always an invisible 1. 1 times b is just b. So 3b's plus 1b, that is 4b's altogether. And 15 plus 2 makes 17. So our final expression here is 4b plus 17. So anytime you see an expression, we want to first check if we can use the distributive property, if there's anything touching the parentheses multiplied by a group, and then we always want to check if we can combine like terms. Example 3, this is our final question today. Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt, Maria, is 3 times Felipe's age. We're going to write and simplify an expression to find Maria's age. So let's start at the beginning with Jose's age. Jose's age is represented by the variable x. His age is just x. We don't have to do anything to it. His age is represented by the variable x. Now let's talk about his brother Felipe. Well, Felipe is Jose's age. Now let's talk about his brother Felipe. Well, Felipe is 2 years older than Jose. So really, he's Jose's age plus 2 years. Well, remember, Jose's age is represented by the variable x. So Felipe's age is x plus 2. Jose's age plus 2. And then finally, Maria, this is who we wanted to find the age for. Maria is 3 times Felipe's age. Well, we have an expression to represent Felipe's age, so we can do 3 times that whole thing. 3 times x plus 2. Notice that I put it in parentheses because I want to multiply 3 by the whole thing, by the whole group. Not just the x, but the x and the 2. 3 times the whole group. So this represents Maria's age. 3 times Felipe's age. And Felipe's age is x plus 2. Jose's age plus 2. So now let's go ahead and simplify this expression. by using the distributive property. Something is multiplied by a group. So I'm going to distribute that 3, multiply that 3 by everything inside. 3 times x is 3x plus 3 times 2, which is 6. So Maria's age can be found using this expression, 3x plus 6. 3 times Jose's age plus 6.